welcome to the channel of Ecoholics. So in this video today, I'm going to solve a past year questions from the paper of ISI Part A 2021. So it's the question number 1 which appeared in the paper of ISI in 2021. So the question is from the series. So the question says, if the nth partial sum of the series is like this, summation an is Sn equals to this thing, 2n square plus 2 divided by 3n square plus 1, then you have to find the summation of series, what it is going to be equal to this thing. So when we have a look at the questions of series, normally we feel confused ki, oh, what they are asking us. So they have given us the sum, why are they asking us again the summation an? So there is a very simple concept in terms of series. So what is that concept is, when I find series, what is series? It's the sequence of partial sums of my sequence, right? So in other words, if I have a sequence over here, A1, A2, A3 and so on till AN. Now S1 is the sum of first term, which is A1. Similarly, S2 is the sum of these two terms. So it's going to be A1 plus A2. Following the same pattern, when I want to find Sn, it is the sum of all these n terms. So it is A1 plus A2 plus A3 plus so on till An over here. So Sn is nothing. It is the sum of all the first n terms of my sequence. So I call this sum of the n terms as my series. But there is one more way. How do we find this sums? Let's say if I have an infinite sequence, I cannot find the last term of this sequence. How will I be finding the sum of this? So in the topic of sequences, what we actually do is, we find the last term. We try to find the last term of the sequence by taking the limit, by taking the concept of limits. So over here also, since as you can see here, like when I move from S1 to S2, one term gets added. Similarly, when I will go from S2 to S3, one term will again get added to this thing, right? So these sums over here, these partial sums which we call, they are also following some kind of order here. So S1, S2, S3, they are also forming a sequence. These partial sums are also forming a sequence. Now my target, I was saying that this is the series, right? This is the series. I wanted to find the value of this series in this question also. But since I can have a sequence, I can have a sequence from the partial sums. So can I take the concept of limit to find the value of Sn? Because Sn becomes the last term of the sequence, right? So limit n approaches infinity to Sn. So as soon as I'm going to take this limit, I'm going to get a value of Sn, where Sn is already giving me the value of series. So it means this is equalized to this thing over here. So this concept is a very much important concept in the case of series, and if you can just understand this thing, all of your questions from series would be done over here, right? So using this concept, I'm going to solve this question. So here in this question, we have to find this value. So let us see how we are going to proceed to this. Alright, the question provides us with this information. They have already written this, that this is equal to this thing. So what approach we have to use here? That we are going to take from our previous slide, which I just told you. So because I want to find the value for this thing, I can take limit to this. Because as soon as I'm going to get this value, I would get my answer for series. Now, whenever you have limits at infinity, how do we solve it? Because if I will put infinity directly here, so 2 into infinity ka square plus 2, it's going to be infinity by infinity, which is, I cannot find the value for it. So whenever we have n raised approaches infinity and I have a function in this fraction form, what is the trick here is that whatever is the highest power of variable in the denominator, I can divide the whole fraction with that. So let us do it. Since the highest power of n here is n square, so I'm going to divide with n square. Right? So this cancels down. I'm going to get this thing. 2 plus 2 by n square upon 3 plus 1 by n square. So let me put n square here as well. Now, whenever n is going to approach infinity, 2 by infinity is going to be a very small number. So it's going to approach 0. Similarly, 1 by n square is also going to approach 0. But 2 and 3 are constant. They will be 2 by 2 and 3 only. So I'm going to get 2 plus 0 upon 3 plus 0. So the answer I'm getting is 2 by 3. So when I took this limit, which is equal to series an, where n starts from 1 goes till infinity, the value I have got for that is 2 by 3. So it means the series is converging. Whenever the sum goes to a finite number, it is known as converging series. So it means the series is converging and it is converging to 2 by 3. So out of all the options, first of all, we have to look whether we have an option related to this or not. So here it goes C option 2 by 3, which is my correct answer. So this was the solution to question number 1 from ISI paper 2021. If you want to see more videos, please subscribe to the channel, like and share this video. Also in the comment box, please let us know which all topics you want videos from our site. We will be happy to make those videos. Thank you for watching.